Okay, we're going to practice finding inverses, and so here's a few functions I'm making up. One that I know are one-to-one. They pass the horizontal line test, so we know that they have an inverse function. So let's do this one. What have we got? F of x is equal to the cube root of 2x plus 1 minus 4. Let's see what would happen there. All right. Let us do that one. Let me do one a little bit simpler than that even. How about g of x is equal to x cubed x minus 1 cubed plus 2. We'll do that one. And then let's do this last one, h of x is equal to 3 over 2x minus 1. These are some good ones. Let's practice this. So there's a really quick 4-step process which we talked about in class before spring break, which I know that seems like eons ago, where the first step process was replace f of x with y. 2, interchange x and y. Number 3, solve for y. And number 4, replace y with f inverse of x. So let's start with number 2. It's not that bad. Let's start with number 2. So we have g of x is x minus 1 cubed plus 2. All right. Step number 1, replace f of x with y. In this case, we don't have f of x, we have g of x. So I'm going to replace him with y. All right. And then step number 2 is interchange x and y. So this is the part where I'm interchanging this. I'm going to say x is equal to y minus 1 cubed, y minus 1 cubed plus 2. All right, so this third step says to solve for y. So we're going to solve for y. Y is wrapped up in here in this parenthesis. So first let's isolate the term that has the y in it by subtracting 2 from both sides. So we're going to get x minus 2 is equal to y minus 1 cubed. I need to be able to get to the y, so now I need to take the cube root of both sides. The cube root. Over here we get the cube root of x minus 2. Over here we get the cube root of something cubed. Those undo each other, and we're left with just y minus 1. To solve for y now we just add 1. The cube root of x minus 2 plus 1 is equal to y. The last step is to replace y with f inverse of x, but since we started with g, we're going to call it g inverse of x is equal to the cube root of x minus 2 plus 1. All right, with number 2, this is g of x, and this is g inverse of x, and these would totally undo each other if we applied them to each other. I'm going to use this one because it's a good illustration one to use. Let us do this. Let's graph g of x. So this is a transformation of the basic curve x cubed, which looks like this. Okay, so what's happening to it? It's going to the right 1 unit and up 2 units. So let's do that. Let's go right 1 and up 2. So right here would be my new xy axis. And so then I'm going to put x cubed curved on here. Let's see. It's going to go like here. So it's coming up. This is what g of x looks like. Okay. Now let's put g inverse of x on there as well, just to remind ourselves how they interact. G inverse of x, this is a transformation of the basic graph, the cube root of x, and it sort of looks like that. So what would happen here? Well, this has some transformation. This is going to the right 2 and up 1. So if we went right 2, up 1, this would be my new xy axis. And so I would get a point there, and I would get a point here. Let's see. This is what this guy was going to look like. He's going to kind of look like that. All right, so this is G inverse of X. The other things I just kind of want to remind you about when you're talking about functions and inverses, there's some characteristics that they have. One is that they undo each other. The second is that the domain of one is the range of the other. And the third is that they reflect, their graphs reflect across the line y equals to x. And so this is the line y equals to x right here. This green. So if you see, if you folded this about these lines, you should see that they would match. Let's look at a little closer at how the domain of one and the range of the other are inverse. Let's pick this spot right here where the origin got moved to. This spot right here is called, let's see, it went right to up 1. So this is the point 2, 1. This x-intercept here is called 1, 0. That's where it's crossing right there. Let's look at the g of x. This one right here, the origin got shifted right 1 up 2, so we go right 1 up 2. This point right here would be 1, 2, okay? And this is passing through the y-intercept here. My drawing's not that great, 0, 1. But here's just 2, for instance, points. If we notice that 0, 1, 1, 0, the domain, the x's, and the range, the y's, are flip-flopped. The domain of one is the range of the other, and vice versa. It's also working on this point. The domain of one is the range of the other, and vice versa. That will happen on every single point of these two functions because they're inverses. Every single x and y point will be flip-flopped to form these graphs. Okay. Then lastly, I want to look at the characteristics of how they undo each other. So if you're asked to take a composition, and you will be asked to take a composition. So let's see. Let's take the composition. Let me leave this on the board and this on the board. Let's take the composition. G of G inverse of X. Also, then we'll take G inverse of G of X. What we should always get is that these undo each other. This should always equal to X. We're going to see if that happens. Okay, and it should happen because these are inverses. If I ask you, and I will, to take composition of two functions and determine if they're inverses, I give you f and g and say, hey, see if these are inverses by using compositions. You would take f of g of x, g of f of x, and if they both equal x, you'll say, yes, they're inverses. But if you get anything other than x, 2x, x plus 1, x minus 3, the square root of x, anything other than just regular old x, you'll say, no, these are non-inverses. Okay, let's do this. G of G inverse would be G of, we're going to replace this with what G inverse is defined to be, and it's this right here. The cube root of x minus 2 plus 1. The cube root of x minus 2 plus 1. All right, go to the G function, and everywhere there's an x, we're going to plug that in. Here's the x, the cube root of x minus 2 plus 1. Oops, plus 1. That's x. Okay, and then what's going on there in the G function is x. You're subtracting 1 from that, minus 1, and this whole thing's being raised to the third power plus the number 2. So we use order of operations. We look at this, we're like, there's a parentheses right there, but there's a positive 1 in front of that. So I don't actually need that. That means I can these two guys, since he's not under the radical, he's free, he can get combined with him. 1 minus 1 is 0. So that means I'm getting the cube root of x minus 2 cubed plus 2. The cube root of something cubed, those undo each other. So I'm left with x minus 2 plus 2, and I get x, which is what I was expecting. We're halfway through. Here's the second half. Do it the other way. G inverse of G of x. Let's see what we get there. All right. This is going to be G inverse. Replace it with what G of x is defined to be. It is defined to be x plus 1 cubed plus 2. So, go to the G inverse function. Here it is. This is equal to the cube root of some x minus 2 plus a 1. And what do I put in there for x? I put in all of this stuff right here. So right here I get x plus 1 cubed plus 2. All right, again, there's a positive 1 right there in front of that, so I don't actually need these. That means that this 2 and this negative 2 can be combined. Those will add to 0. So we get the cube root of x plus 1 cubed plus 1. All right. The cube root of something cubed is just the something. So what comes out of this is the x plus 1. Did I write something down wrong? Let me just double check. Yeah, I did. This is wrong. When I wrote down the g of x, I was supposed to put x minus 1. I noticed that now. That should be a minus. So this should be a minus. So this should be a minus. Okay, now we're okay. So now, the cube root of something cubed is just the something, so we get x minus 1 plus 1. 1 minus 1 is 0, and we just get x like we were expecting to. Okay, now, real quick, I'm going to do number 1, I'm going to do number 3. We're going to find the inverse